Welcome to this code package for running a Flashloan smart contract on the BNB or Binance chain for doing PancakeSwap v3 and also PancakeSwap v2 swaps. And so what this video is about is how to actually just get everything up and running so that you can get to editing or changing any code to fit your use case. The first thing to get started is you need to make sure that you have Node installed and TypeScript node, and also Yarn. So just make sure that you've installed all three of those globally. And once you've got those installed, you also need to have Git, because of course, with CodeRaiders comes the GitHub URL above that you can use to go and clone the Git repository that you'll find here on the page of this code package. So once you've gone and git clone and then the correct URL, so replace this with the correct URL for this GitHub repository, and then add a project name, whatever you want to call it. I've called it my project so that you can see you can change the name. So once you've done that, then we should be able to move on to step 2. And that's where I am right now. So I'm in VS Code. I'm ready for step 2. I'm going to open up a terminal here, and you'll see that everything from the GitHub repository has now been downloaded over here. So I'm ready to get started. Now, if we follow the instructions, we can see here the first thing we need to do is create our environment variables. And so we can do that by going touch.env, and that will create a .env file here. You can also just right click and of course go new file, and we can now paste in our environment variables here. And you can copy these exactly from the code package repo that I've got here at coderaiders.com and just paste them exactly as they are in here. And so here we have our mainnet provider URL, which I'm just using the standard Binance Smart Chain URL. And of course, you can use any URL you want. Alchemy and Fura, localhost 8545 if you're running your own full node. And here I'm doing the same thing for testnet. Now, this code doesn't use a testnet, but just in case you wanted one, I've provided the testnet provider URL here as well. The private key is actually used over here when it comes to using the mainnet network. You can see here's where it takes in a private key because it has to deploy it to the mainnet, and therefore it needs to spend gas and take money out of a wallet, which will be your wallet, and it knows to do that through a private key. So what I'm going to do over here is I'm going to go to my MetaMask and I'm going to log in, and then just click up here on your actual account. And then on these three dots, you can select here account details. So you might not be using MetaMask, that's fine, as long as you know how to get your private key. And here I'm going to say show private key. I now have my private key copied, which I'm not showing on this video because this is a public video and this is a private key. You should not share your private key with anyone. So what I'm going to do here in my .env is I'm going to get rid of this text here. And I'm just going to put 0. So this is not O. You don't want O, you want 0. X, lowercase x, and then paste in your private key straight afterwards. Now I've just made up a pretend private key here, so mine looks really strange, but your private key should look something like this once you've pasted that in. And remember, having the 0x to start with is very important. Great, that's our .env file or our environment variables now set up. So the next thing we need to do is install our packages. And so it's very important that we use the exact versions of the packages that I'm using. Otherwise, this might not work for you due to various code updates or whatever. So the way to do that is to go yarn -- exact, just like this, and hit enter. And that will go and install all of those node modules for you. Once that's done, we can go npx hardhat compile. So let's go and run that here now. And that should go and compile all of our Solidity smart contracts. And here you can see it's added an artifacts file. This actually has our contracts with our ABI for our Solidity Flashloan smart contract. And I'll take you through that in a moment. We've got our cache, we've got type chain types here. So it's installed everything that we need. And the reason these are grayed out is because if you upload these to your own Git repo, it will not upload those folders. So that's great. We've got all of that. There's nothing you have to do there. Now all we need to do is make sure this is all working. So we do that with npx hardhat test. So I'm going to go and run that now. And let's have a look over here. This is looking like it's working. And there we go. It's worked. We have successfully deployed and performed a swap on a Flashloan smart contract. Now I'm going to talk about that in a moment because there's a way to do this test, and I'm going to talk you through that thoroughly so that you understand how everything's working and therefore how to go and manipulate this for your own needs. But before we do that, I'm just going to show you here that step 5 works as well. In other words, deploying this to the mainnet. So what I'm going to do here is go npx hardhat run scripts deploy flash, and you can see here now I'm choosing the network to be mainnet. And so when I go and I run that as such over here, you can see that it knows my account balance and it's now deployed that contract to the actual mainnet. And actually, if you took, for example, this Flashloan contract deployed address, you would see this is now on the BNB chain blockchain. So here under scripts and deploy flash over here, what I'm going to do is I'm just going to add this address in here for myself. This is typically what I do as a reference, so I know where everything is that I've deployed. Of course, I could go to my account on BSC scan and see the transaction for deploying this to the blockchain, but I don't need to here. Now this deploy sim, you can ignore this. I was using this for other development over here, so this doesn't really do anything right now. And for now, that's fine. We don't need that. So perfect, congratulations. You've been able to not only run a Flashloan smart contract on a forked mainnet, you've been able to then successfully deploy it to the mainnet. So that's how to get all this code up and running, and hopefully you've been able to follow those steps. But now let's talk about how this actually works. So first of all, I'm going to go here to test and flashloan test.typescript. Now, for some reason, because I've got lots of other, or been using lots of other VS Code projects, it's not aware that I've got ethers on my VS Code right now. So it's looking for that in a different place, and it's showing me a red squiggly line. And that's just an issue I've got right now I need to resolve. It shouldn't be an issue your side, it's an issue my side for me. And so what I'm going to show you here is this is how that test actually worked. So what it's doing is it's running this test for Binance Flashloan PancakeSwap v3, and it's going through this exchange route. So a 1 means the first swap will happen through Uniswap v3. If I had 110, the first swap would happen through Uniswap v3, then the second one Uniswap v3, and then the third one Uniswap v2. If, for example, I had 0 here, the first swap would take place on Uniswap v2, the second on Uniswap v3, and the third on Uniswap v2. So 0 means Uniswap v2, and 1 means Uniswap v3. The v3 fee here, if you don't understand how Uniswap, or I should say not Uniswap, I should say PancakeSwap. If you're not sure how PancakeSwap works, it has different liquidity pools. And so to reward those providing liquidity, there's different size fees, and therefore there's different pools with different size fees. And so you have to be very specific about what pool you're working with. So if you're working with Uniswap v3, you can start with the pool, say 500, and it goes 500, 3,000, 10,000. In fact, I think it goes 100, 500, 3,000, 10,000. The path here is Cake and WBNB. So Cake is Pancake Swap's token here, and so this is the arbitrage swap we're going to do. And so this will say, okay, on the first trade, take what you borrowed on the Flashloan, swap it for Cake, then swap that for whatever you have Cake there, swap it for WBNB on the next trade, and then on the final trade, it'll take WBNB and swap it back for BUSD on the Solidity smart contract. And you can choose whether you want to borrow WBNB or BUSD. And so if I scroll down over here, this just creates an impersonation of a wallet, of a whale's wallet address. And so this whale address, BUSD, might not always contain the BUSD you need. And so you can actually go to this link I've provided up here if your test didn't work, and put in different whale wallet addresses that you know have a balance in. And so what this code does is it just impersonates that whale. So when you impersonate that whale, you then essentially pretend having access to their wallet when you're forking the mainnet here using hardhat. So that's very useful. You'll impersonate the wallet. It then deploys the Flashloan smart contract, and it deploys it with WBNB and BUSD as the two potential tokens you can borrow. This represents token 0. This represents token 1. So if I send a Flashloan with token 0 amount in it, it will then go and borrow that amount from Uniswap. I say Uniswap, it's the Uniswap v3 code, but it's working on PancakeSwap v3. So that's what this here will do. And then if I scroll down here, what we're doing here is actually paying 50 BUSD to the deployed smart contract, because it's probably not going to be a profitable swap. It's very unlikely. You'd be very lucky if Pancake versus WBNB had a profitable swap between these exchanges over here. You'd be very, very lucky. That would be a big coincidence. And it has happened to me before, but it would be a big coincidence. So here for testing, and this is only for testing, we actually go and pay BUSD to the newly deployed contract so that it's always going to have a profitable amount in it to pay back to us. And that's how we can test that the contract's actually working. If you genuinely wanted to know if this worked, you could put this to 0, and then I could go npx hardhat test. And when I run that over here, you'll see it should actually fail because it's not profitable. And you can see that actually did fail. If I scroll up here through all of this noise, all of this red failed code, you'll see here it says BEP20, transfer amount exceeds balance. And so this is because I set this to 0 and it's not profitable. If it was profitable, that would have actually succeeded. And so here I'm going to put that back to 50 and keep scrolling down. And then what it tends to do here is to borrow 30 BUSD as part of the actual Flashloan. And here's where it creates that contract. So it connects to that Flashloan contract here using ethers. And here's where it actually sends the Flashloan request. So it sends the token path, which we know up here is actually Cake and WBNB. It sends it for the routing on the exchanges I showed you above with the V3 fee and the amount to borrow, which is 30 BUSD. And remember, the contract also has an additional 50 BUSD in it just to make sure it's going to be a profitable contract. You wouldn't do that in real life. You put that at 0, and only if the arbitrage was profitable would it actually work. And there we go. That is how we go and call that Flashloan. Now within the Solidity smart contract, you can see I've got a whole bunch of code here, but the bit that you're going to care about is down here. Now you can console log using hardhat. That's why when I run this npx hardhat test, I'll run it again. That's why when the Flashloan contract itself is actually running, you can see these printouts here. And this is very useful for debugging. And it calls this place swap. So there's some logic on a function for place swap between Uniswap v3 and Uniswap v2. You can get into that in more detail. But it knows based on the exchange route whether or not this place swap should take place on Uniswap v2 or v3. It knows based on this place swap function, which is further below. But this is the main bit you're going to care about here. Here's swap 1 taking place, then swap 2 is taking place, and finally swap 3. And you'll see here this D56 address is actually BUSD. So we're starting with D56. That's what we're borrowing. We're borrowing 30 BUSD of D56, which is BUSD. And we're paying that back at the end. We're ending up with that amount. And if we have an excess of that amount, it'll pay it back. Now, if you were borrowing WBNB, so you were using token 0, if I scroll up here, if you were using token 0, amount 0 instead of amount 1, that would mean you're actually borrowing WBNB. And here you're borrowing BUSD. And so that's what this means over here. If you go and use amount 0 with an amount and put this one as 0, it actually knows that token 0, what it's borrowing is WBNB. So you can choose whether you want the Flashloan to be for WBNB or BUSD. And if you start getting really advanced with this, you can actually select other tokens as well. And so that's what this is doing down here. It's deciding how to then pay that back. So it's approving for the full balance of that token here for this smart contract. And then it's paying back the Flashloan, because that's the rule with the Flashloan. You have to pay it back. If you don't, the transaction will fail. And then any excess left over, it pays to you as the person doing arbitrage. And it does it for token 0, which is if you're borrowing WBNB, and it does it for token 1 if you're borrowing BUSD. And that's how this Solidity smart contract code works. This is not, of course, a whole course on Solidity, and I will be covering this in more detail at the Code Raiders YouTube channel. So if this is something that you feel very out of your depth with, and you want to get to understand it further and deeper, then go to Code Raiders at YouTube and look out for the playlist that I will be creating. It's not up yet at the date of recording this video, but I will be doing videos on it very soon. So hopefully by the time you see this video, it might start appearing. Now, it's taken months to figure out and learn how to get this working for PancakeSwap v3 amongst running a search algorithm as well. You can see a video of that at the Crypto Wizards YouTube channel. However, I want to make sure that this is now provided to everyone. So you are now able to go and use this code as you like. For me personally, I can't find many profitable arbitrage opportunities on Binance Smart Chain, but that's not to say you won't be able to. And that's why I wanted to give you this code. Till the next one, take care and talk soon.